Welcome everyone to second to last session on the SQL Day 2025. As always, I want to thank all the sponsors for being able to have this great conference, and also to mention that Lingaro is again a sponsor this year, a gold sponsor on the conference. So if someone wants some gadgets, can sit at the front. There's still some, and also if you didn't do it already, you can find our booth to talk about our company. So we encourage you also to look for more than 30 people that are here today at the conference if you want to know more. But let's jump to the topic of today's session. That will be about partitioning approaches and insights about in different database systems. It will be Oracle, SQL Server, and PostgreSQL, and it's kind of the importance that while we have Databricks, we have Snowflake, which are column store databases and analytic platforms. When we kind of store the data in a columnar file systems, kind of partitioning is more natural for us to be applied and easier, but it's good also to remember the roots and the partitioning in the classical RDBMS systems like those three. So, shortly, 2 words about me and Sarah. So, my name is Szymon Lasota. I'm cloud architect at Lingaro. We're working with data over 13 years and in Azure over 8 years. Since 2020, I'm also a Microsoft certified trainer with a few certifications, always also leading in Lingaro the community of Microsoft competencies. And Sarah?
And my name is Sarah, and I'm currently data integration engineer, and I like to say that I grew up from Oracle, although I was first there only an internee. And then I had my first hands-on experience in Postgres in some small company. It was actually more like a startup. And then I realized how much more Oracle has to offer. And I went back to Oracle. Then I certified myself, and since 4 years working with Oracle technology in Lingaro.
All right. And brief look on the agenda today. After a short introduction, of course, we want to cover the basics, so we're on the same level. We'll go through the SQL Server, then Oracle, Postgres, and if we'll have enough time, we'll go to the Azure implementations of SQL. But let's not jump to the conclusions, and let's start with partitioning introduction.
So, small introduction for everyone. Working with large databases, with large volumes, is usually a challenge because there is a storing, there is writing or reading the data, and we need to think what we focus, what we care the most. So, rather than jumping into technical solution, it's also a good it's also good to take a step back and ask more generic questions. Why we need the data, what we will do with the data. Maybe we don't need access to the whole data. Maybe we want frequent access to some part of the data. And I would give example of the data that I work with, which are sales data for the whole world, so all the regions. It's global data. And we often need only recent data, and we often want to focus only in specific region data. So we need to think if we want to more invest upfront and put more time into maintenance and then benefit from faster access, for example, and bigger flexibility. And today we will present partitioning, which is basically dividing large objects, in this case large tables, into smaller pieces that are more manageable. And each partition holds a subset of the data, and it behaves for the database like a separate object, completely independent. So each of them can be queried or stored separately and can be maintained separately, but it still appears as a single logical object for the end user. So you can see here the logical view of the non-partition table, and then partition table, which is still represented as the one object under the same unchanged name. And you may ask yourself, why partitions, not indexes? So I titled this not only indexes, because those are not alternatives. They are really connected in the concept of partitioning, because you can index partition, you can also partition an index, and you can put index or partition on two completely different columns. Both can be applied, and the engine will still analyze what is the best path to get to our data. So an important question is why we need them. If we work with large volume and we want to access bigger portions, then the answer would be partitioning. But indexing would be good for finding single rows, because it's more like finding needle in a haystack. So if we have the sales data that I mentioned, it would be good to partition for the whole region, or for example, for the whole month of data, while indexing would be good for partitioning, for example, customer ID or some specific products, because the path that it needs to go for partitioning is going just straight to the right partition, while in indexing that you see on the right side, there still needs to go through the whole mapping to find the correct value. So if we decide to apply index on a date instead of partitioning, this is an example of what we shouldn't be doing. Index would store the values from the index column, and for each of the value, it would store the location, so the row ID. And that for the rows that have the value that we are searching for. And the mapping of this, sorry. And the mapping of this is organized in a tree, and this is an example of the default most popular B tree, and it can navigate the query to the correct location of the desired rows. But it slows down the retrieving process, because it usually requires still scanning the whole tree and getting to the leaf. While in partitioning, it knows immediately, and it's just ignoring all the partitions, going straight to the partitions that we need, and it is called partition pruning. Oh, and I wanted to add something also to the previous slide, that here in index tree, in case we would like to insert new row on or update existing row, it would rebuild the tree. So it costs more, while in partitioning, we just remove one partition, we can drop or truncate the whole partition, so it's also a faster process. And it is important that there is no impact on user view. There is no query changes needed. The application still can use the same query, and it will behave like a normal table. So you don't need to specify which partitions are you inserting to, for example, or retrieving from. The application will still use the same logic without rewriting the query. However, there are some rules that you should follow to benefit from partitioning, and I will explain them in a second. Just for you to understand that underneath the table, it will be just splitting the existing rows based off the value on selected partition key, which is one of the existing columns. So it can be selected per our business use. Here is a small reminder for those who don't think about this every day, that the execution order is not the order that we write the query, but is the order that the engine will analyze to retrieve the data. So before even this steps from 1 to 7, I would call there is a step 0 when where query planner checks the filters and filters in a join and where condition. And the actual execution, the engine will check the rows if it can already select desired partition and omit other partitions. So you need to carefully put the where expression, because only after that it will go to group by or having expressions on the data that are already retrieved. So here are some examples of correct and incorrect applied where clauses. It must be either simple comparisons, because it must be translatable for the engine to understand what we are looking for. And here is actually example for Oracle, because it has this implicit data understanding. This is given as a string, but this will be converted into date. So we can use, if we partitioned by date, we can use it explicitly by given date or between. But once we want to put a function or some calculations on a column that is used for partitioning, it will still need to perform this calculation on each row. So it will be not translatable for the engine. And here I have some small demo to show you, to prove you that it is actually happening. The demo is basic, just to show you that we are really omitting and pruning the partitions. For the sake of this demo, to not go through creating tables and so on, I created 3 tables before. They look like this. And they contain data between 1st of January until 31st of March, so 3 months of data. And I created one table that is non-partitioned here, one table that is partitioned by month, and one that is partitioned but by days, so daily partitioned. And they all have all the same data, and the difference is only partitioning. So if I go to explain query, and I want to perform very simple operation, which is sum on date on 1st January. Let's check what will happen. You can see that this is a correct applied filter, correctly applied filter. It directly went to partition range single, so it went to straight to the single partition. While when I would apply the query in a poor way, so for example sales date plus 0, which is still the sales date, but the engine will need to perform this operation on each row. And if I explained this, oh, sorry, but you see it's taking a lot. Let me stop this. It's explained. It goes to all the partitions and it scans them all. So we didn't really gain any benefit from this. And one thing I would like to highlight here, because this is something I got used to and I got a little bit lazy about this implicit this implicit transformations. When I use a string, it will be treated just the same as date. So I will come back to that later. Just remind now that this will work just the same as correctly applied filter. Still goes to range single. And this is now for the demo. Let's go to deep dive into SQL Server.
Okay, so switching. Alright, so Before we will jump to SQL Server, also after this introduction to partitioning that is mentioned in context of the partitioning, actually the tables and the indexes, but also let's think about the other important aspect here about the physically dividing the data into separate data stores. So there are like three, I think, major data strategies that are being used. And first one, the horizontal partitioning, is what we have seen, that whenever we are already defining on which column we want to split the data to different shards, then different partitions, different, it could be different on different locations. Then this is the classical thing when we're thinking of partitioning, but there's also other aspect that's called sharding, and that's kind of the approach also available in, for example, Azure SQL, Elastic Pools, or Cosmos DBs, that whenever we are splitting this, applying this horizontal partitioning, we are putting it to a different database, to actually different physical location of different data stores. So sharding then is more in context of the physical separation. The second approach, the vertical partitioning, is less popular in the RDBMS, but in column store engines is more frequent. So whenever we have a need to kind of separate the data that is being changed slowly and dynamically, we can separate it to vertically to different tables or different, because that's not something that we could do with the partitioning functions that are available natively in engines. So, like in this example, the name and the description of the product and its price is something that is not frequently changed, but the application would need to operate on the stock amount and the orders frequently. So also for the sake of the concurrent access of the data, also with the being able to cache smaller amount of the data, we can apply this vertical partitioning. Also, it could be needed for the security reasons whenever we have some sensitive data that we just cannot store at the same data store. And the third one, the functional partitioning, is less frequently used, but it's worth to mention that whenever there is kind of a possibility to identify a bounded context for our distinct business areas in application, we can split them also to different data stores. And that bounded context is kind of the central pattern of domain-driven design. So in those situations, such functional partitioning concept could be used. But moving smoothly to the SQL Server deep dive on the partitioning. So I'm not, if someone was yesterday on the session from Maciej, that was really great session with a lot of demos. We'll be covering here basics and then focus on the Oracle and Postgres, but I also encourage you to watch the recording whenever it will be available if you have not been on the session. But then let's go through the structure of the how SQL Server is doing the partitioning on the tables. So very first thing, we need the partition function to be defined, and in partition function we are deciding on which column and which this type will be contained in this column we are going to split our data. And in SQL Server, that's the important thing, that we have the possibility to use the range partitions. You'll see later in other RDBMS you have other types of partitioning available as well. So within the partitioning function, here we're defining that we'll be separating our partitioning our data by the date column and by months. As you can see, then when we have that applied, then we are defining the file groups, how we are going to split it on the physical storage. So very important comment here in Azure, we are always applying this to the primary file group. We are not able to kind of create any custom ones because that's a platform as a service and we are not managing the storage. But in the background, Microsoft is doing whatever possible to kind of manage it properly. And with hyperscale, we'll have more flexibility there, but I will say about it later. So when we are defining the file groups, then also we can assign the file groups to the database files if we're on-prem, and then we're creating partition scheme, which is the connection between the partitioning function and partition scheme, which then allows us to apply the actual partitions on the tables that we are going to partition with those function and scheme. So let me quickly go here to show it to you on my computer. So I will show you two examples, very simple one whenever we are creating from scratch and whenever we are doing changing existing table. So like mentioned, very first thing we need to do is define the okay, it's far better. So creating the partition function here, it will be based on the datetime column, datetime data type, not column, and we are defining that it will be a right range for those 3 months. Then if it would be on-prem, let me execute it. If it will be on-prem, then we would also define the partition, the file groups that we could use and apply the file groups to the actual files in the file systems. But then the thing, whenever, because I'm on the Azure database here, the second part is to create a partition function, partition scheme that in cloud I'm applying to the primary file group, and with the all2 statement, whenever we are on-prem, then we would like to assign it to a different file groups that we have defined. And then the very simple table with column 1 primary key on which we will be partitioning, because that's the important part that we need to we have to have this range on a single column. In this case here, let's create the table and let's look at the with this query that we could quickly check that the table was partitioned with the my range partition scheme, and also we could look at the, we see there are 4 partitions with the boundary values on the right, and at the end we can also run such query to identify the partitioning column if we would like to search it with whenever we don't know. And the last one query I would like to show quickly, we can also have this also with the number of the rows and the ranges explained in a more readable way, whether it's left or right, to identify that. And in more complex case, we'll create a table that we have the primary key, but we want to partition on a different column that will be a date time. So we need to have this primary key clustered first. This is preparation created before we will do the partitioning. We'll also insert there some test data, and whenever it's ready, we'll be able to see within this that we have one index and the primary key and the clustered index. So we need to when we identify that we want to actually have our partition based on the datetime column, we need to create partition function with here defining four partitions with 4 years. Then partition scheme, again to the primary file, we're just connecting the primary function with the primary with the scheme. And quick look here to see that right now we have all the boundaries defined from the first example and from the second one. And to If we would have any foreign keys on this primary key, of course, we need to drop them first. Then we need to alter the table to drop the constraint of primary key. We can create the non-clustered primary key because that's still our primary key from the business perspective here. And then at the end, we can create a clustered index with applying the partitioning scheme. So we can apply it like that, and with it we can see the partition table. And let's see actually the last query that will show us the row counts and the ranges. So we see that data was already partitioned as we expected. Right, so if you'd like to see more deep dive, then I recommend the session from yesterday, and I think we can move on to the next slides. So Oracle.
Okay, so hello, test, raz, dwa, trzy. I don't know if you can hear me. More or less. Okay.
Yes. It's okay.
So the characteristics of relational databases is that the logical objects are independent from physical storage objects. And because they are separate, you can manage physical objects without affecting actually access to the logical data. Oracle stores the data in a logical unit called table spaces. So in each table spaces you have the default system, and you can also create additional ones. So in each of the table spaces there are segments, and each of the segments represents exactly one object, for example one table or one index, or in the case of partitioned table, each partition will reside in one segment exactly. Because they have separate table spaces, you can put them on different disks. You can put, for example, table space 1 on fast disk and assign them most recent partitions, and another partitions put on slower disks. Yeah, because table spaces, they correspond to physical data files on disks. And segments can share different files, but they can never share different table spaces because they are separate files or separate disk groups. So each of the partitions can reside in a completely separate storage and have its own storage attributes configured. For example, like I said, for archive data on slower table spaces and cheaper storage rather than on fast one. But the key point that under the hood there are still the logical object is still visible as single object, but partitions are separate storage objects underneath. Buffer cache, a pool of memory for caching data blocks read from the disk. Partitioning does not introduce a new cache. They share the same buffer cache, but it affects indirectly what stays in the cache, because if queries targets the same partition often, some subset of rows will, subset of blocks will read from the disk will remain in memory more often, while the old partitions that are not read because they are omitted during the query, they will not block and they will not clog the cache. Query Optimizer uses partitioning metadata to do the pruning. So for range or list partitions, it stores the high and the low boundaries for each partition. And for hash partitions, it knows the hash function or the number of partitions to compute the target. And each partition is independent. It's different segment. So it also enables the parallel query execution. It can be done via hint or when you mark the table as possible to parallel query, and it also thanks to that, it can join multiple processes, and each of the process will operate at the same time on different partitions. So if you have 12 partitions and you have, for example, 4 parallel query workers, you can assign 3 to each, and they will operate independently, and they will merge the results. Oracle has the most possibilities to do the partitioning, and I would list it 4, but in fact there is also additional one. The first one that Szymon already presented is range partitioning, but it's a little bit different, but I will show you in a second on a demo. It's good for numeric or data values when you can specify the range. There is also list partition possible when you, for example, for categorical data, when they don't make any sense for the computer, but they do for you or for your business. So categories, products, or some countries. And hash function, hash partitioning, where you don't have really idea how you could split the rows because they don't have really logical groupings, but you often hit that in your queries, for example, customer ID, and it will figure it out for you, and it will split for even partitions, so it doesn't have to go to each one every time. And the composite is just the connection of 2 of those. First one can be range or list. The second must be list or hash. No other way possible. And the 5th one that I didn't list that is actually a range, but on steroids. So it's on autopilot completely. You don't need to maintain. You don't need to maintain partitions. You don't need to create them before, because the engine will do that for you exactly the same way, but behind the scenes. And now let's jump into the demo.
Yep. So let's switch.
So I have created different table spaces for the sake of this demo. Just wanted to show you that they are here. Remember that in Oracle from 19 plus, it's multi-tenant architecture. So if you go to system, you want to create an object like user or table space, you need to connect to the correct root, because by default you are in some CDB root, which is system root. So after connecting to the correct one, I created here already slow and fast table space to show you. And they are listed here. And I can see them. Default one was users. I created 2 additional one. Now I created also pre-created some unpartitioned sales data demo, because I wanted to show you how to create and load a partitioned one and assign correct table spaces. For example, here, it's the same data I presented previously. It's January, February, and March, and I assigned the most old one to slow storage, and the newest one to the fast storage, and then I assigned those in between to the default one. So I mimic the tiered storage in this case. So let's create the table. It's created. I can refresh it here. Yes, demo partition range. And now let's insert the data. Of course, normally you don't insert straight to the table that you want, but you create staging table and then only do the exchange partitions, because you don't want to block the table from an application that is using it. But this is a simplified demo. And when I would be creating, inserting the partitions, one important and curious thing about this is that it is defined as it defines only the upper boundary here. the first one is only less than February. This means anything, any garbage that will arrive will reside in this partition, and you need to be very careful to monitor it. And the rest works similar like in SQL Server. This one, the last one, is optional, but it's better to specify more the partitions up front and have them empty rather than store all the data in one partition, because it's always good to keep evenly loaded partitions. Otherwise, if I have, for example, 90% of the data in the last partition, I will not very much benefit from the partitioning because getting to the desired data will still scan lots of rows. So the data are inserted, and I can also check the partitions that appeared here. Yes? Yes. Yes. Sorry, I can't hear you. Yes, it's different. You need to specify them, but I will show you now that there is an interval that was introduced recently by Oracle, and then you don't need to really specify it because it will do it for you. And I also want to see the table spaces where my partitions reside, so if they were assigned correctly. So I can see that it was assigned just as I specified. Now I wanted to show you, because okay, I created the partitions as you noticed. I created them for months, but let's say I don't need data monthly because I'm more interested always into last day in my work. I run all my reports on last days, for example, for yesterday's data. There is no sense of splitting in month. Let's split into daily partitions. Okay, but I don't really want to, create all this code to create daily partitions and specify each of them. And it's a good solution to run wrench on autopilot, as I call it. So I just created the table with the partitioning still by range, but the daily. And I will see if this appeared here. Hey, yes, it's here. And it's my start partition, which I had to give. But if I start to inserting the data, the magic will happen, and all the partitions will be created behind the scenes. So I can only care about removing archive partition. Yes, demo always takes longer than when it's prepared. Okay, I will go back to that to show you that they appeared, but trust me, they do. Oh, it's okay. It's there. Hey, all the partitions here created. Hooray. And the last one I want to show you, I don't have, unfortunately, time to go through all of them, but I could create also a range, or for not range, but for list partitioning. And I would specify the exact value for each partition, and also for those that will not match, for error values, I will put them into default P order partition. And I use this one daily. I work with global data that arrived every day, in billions of data arrived every day for each region, and I choose to partition by range and then by string of data. And why do you think it's like that? Why we don't partition by range? single range or maybe composite range then region. Why we choose to partition by firstly by region, then by date. Okay. Yeah, because we choose this combination of region and string. And in global, if we work with global data, usually it's access for the data for specific region more important rather than access to the specific date. Regions wants to access their data, and then maybe some range for the dates, but they don't want to access the whole data. And also one funny example is that I work with different time zones, different date formats. And if I go back to the sales data and you look at the sales date here, and I remind you that is converted implicitly by Oracle, so I usually use a string like I used here. Then I have more work if someone from abroad is sharing code with me and they have different format specified. So when we specify by string in format like this, we avoid those situations. I don't need to go through the code to change it to make it align with my date format that I have on my computer. And this is for the Oracle. We don't have much time to go through other demos, so I will just jump into back to the presentation and tell you about the concept of Postgres and partitioning in Postgres, which is completely different than SQL Server and Oracle. Okay. So Postgres storage architecture is similar in a way of logical and physical objects, but the concept is that you are not creating partitions, but you're creating completely separate child tables. So first you create only kind of shell, empty shell, and there you have only information about the structures, about the partitioning method that will be used, and that maybe underneath there will be some tables to look for, the child tables. And each of the child tables is completely different, completely independent table, and it behaves like normal table, so you create it also with create table statement. And just like in Oracle, child tables can reside on different storages. So you can put, you also can imitate here this tiered storage by putting them on different table spaces. And it only knows from metadata which child will belong to which parent table. And it's also like in Oracle that they share the memory and they don't create all the pages that are read. They are treated as the same table pages. So the hot partitions will reside more in cache rather than the cold partitions due to frequent access, but there is no dedicated memory in partition. And the definitions, just like in Oracle, of ranges or lists are values. They are stored in the catalog. And I show you where is it, and it links them to the parent. So when you are inserting, Postgres will check the value and routes the row to the correct child table. But the parent table will never have rows on its own. And because of this architecture, you cannot create global objects. Like you cannot create an index on parent table because it's empty table, there are no data, so you can only go and create a separate index on each of child tables. But you can, thanks to this, you can also attach or detach child from parent. So you can, instead of exchanging like you have in Oracle, exchanging partitions, you can detach or attach a new table. And this is coming from the legacy that was implemented before they introduced partitioning. Before, it was possible to achieve partitioning with some workarounds, because you could define the table as a parent. Sorry, wrong visualization here. I wanted to show this one. You could define the child table as a legacy of the parent, and you could add additional columns. And this row, you need to choose if this row physically resides in parent table or in child table. And this gives you more flexibility because of the structure, but you cannot select from child tables and know what was in the parent table, but you can do the other way around. So you can take the one parent and knows what is exactly in each child table because it's shared the same columns. While in classic partitioning now, you have to watch the same column numbers, so all the structures, data types, and here not. And here, if you try to insert the data, you are not able to insert data through the parent to the child, because how you could pass the information about this extra column, it's not really possible. And this is how you treat these objects in the database. You just treat them separately. And thanks to this, you see the nesting. It is actually possible to do multi-level nesting, even up to as many times as you want, but it's not very good for the performance, so it's advised to go maximum up to 3 levels. And once table is defined as partitioned, you cannot change them you cannot change it into non-partitioned, and vice versa. You need to drop it, and so, for example, detach all the kids and then drop it. And I want to show you how does it look in real life.
Okay, so let's switch.
Let's switch.
And you didn't mention the types that are available.
Yes. Good catch. So the types are really similar to Oracle. So it's range, it can be list, hash, or the multi-level. I call it multi-level, not composite, because it's actually a nested table. So each of the nested table can have its own type of partition. So when I create the parent, all I need to specify that it will be a partition by something, by the column, and that's it. Habits. Hey, table is created. And then I need to create, for example, 3 child tables. An important here, and the difference between Oracle and SQL Server is that I can have the range, but I also can choose. I can give the range and then leave that first partition open, so anything below that will cause an error, or I can specify it as min value, so it will be existing partition that will hold everything, all the garbage, I would call. The table is created. Let's repeat it for 2 different. So the middle one, as you can imagine, has also the range from some lower boundary to upper boundary. It is defined. But the last one for my data also can be to the max value. But this time I will use also range to show you how looks the error. And now I can verify if the partition were created. Hey, created here. This is the main one. these are partitions, so actually a separate tables. And if I want to check the relations between them, the parent to child relation, they all belong to sales data. So now the question is if I can actually insert data straight to the parent table. It will be routed or not. So I can explore you that it will be automatically routed to the correct child table. It was inserted, and I don't need to commit because commit happens behind in Postgres behind the scenes. And so check if there is something in parent data. Yes, we have one inserted row, and what is inside of our child table, there is also the same row, because this will have information. The parent table will always give you information about all its child's rows. And now I want to show you that you can also, which is a good advantage, big advantage, you can insert the data straight into child, and they will appear in the main table, in the main parent table, as well as in child table. But let's try to insert data outside of the partition ranges, and let's see what they will say. This is main table. It was partitioned only up to the 1st of April. This is 2nd April. It's outside completely. Error. No partitions of relations. So I cannot. And let's try to enter this data also to some child. This violates partition constraints, because behind the scene it checks, it creates a constraints on the partition definition that is created for parent table, which is passed to the child table as constraints. So now I can show you how you can detach partition from the parent table. I detach partition very simply, but I'll alter the parent table. And now, if you go to check the tables, they are still here. But let's see who is now father or mother of our detached table. No one. It's table on its own. So I will just drop it. Okay, something is here. I dropped the detached, and now I can show you if I would have some completely separate table, and I will try to attach some incorrect partition to my parent table. So it's a small quiz for you, so small why this one will not work. Nope. There is something about the structure of it. I can give you that. So I added some extra column here. The parent does not contain the price column. I just added this to show you that if the structure would be different, you cannot connect those in the relationship parent-child. And if I play this one and I created this, and I try to alter this parent-child and attach this one just newly created, oops, contains column price not found in the parent. Okay, let's remove the column price. Let's create the one that is matching structure. But now I specified the wrong dates for because they overlap each other. The previous one was already covering the 2nd of February. This one is already existing. If I try to attach this one, yes, it's overlap partition. So the last but not least, let's finally attach correct partition. Oh, I think I was doing the demo before and I didn't remove those. It's created. Not much to check, only the structures and maybe some constraints. And let's go. Hey, it's there. And I can check that now I have some new tables, and if I check the relations, now I have this wrong name because it's correct, but you see that it's appeared under. So this is the concept of Postgres. Unfortunately, in this session, we don't have time to go into details very much, but I can pass my voice now to...
There is a question, I think.
Can I create an index on partitioned table on Postgres?
So if you go to the presentation, I will show you. The presentation is better because it will more visually explain this. Because the answer is depends on which one. So here you see there is a parent table. You can see my you don't see my pointer. So there is a parent table, the black one, and the black one is only a shell, and it has no memory assigned. It has no rows inside. It's completely empty table, and the tables inside, they are only assigned to this by metadata, but they are completely separate objects. So you cannot create global index on the parent, on the shell, because it does not have any rows. So how could it work if it does not have any rows? But you can create on each of the child separate indexes.
But, the indexes could be built on different columns?
Yes.
Interesting. Okay, thanks.
But what if you create an index including your range or list, and then you redirect you to the right partition?
Sorry?
You can create an index on parent and include the column you made the partition on, for example, the list or the range, and it redirects you with the index to the correct partition. But you have to include this range or list you made the partition of in the index.
But you are telling from your own experience,
Yes.
or okay. So this is something new for me, because when I was working with Postgres and I was preparing for this presentation, reading documentation, it was explicitly said it is not possible to create an index on the parent table, and also I was trying to do so and it didn't work. So I never heard about that one.
That might depend on the version as well, probably. And also one question from me. Can you do like relative date ranges here, like this year and all the previous years? Or this is something someone would have to like code around?
Sorry, I don't know if I get your question right.
So like in the examples you do ranges for specific dates.
Yes.
So could you do like index for this year and all the previous years? Like so the this year is like always current data of the current year that we are analyzing like regularly?
So like the interval, like in Oracle, right?
Like interval. No, interval is only specific for Oracle. It's like it's actually their flagged product. So for other, you need to you can a little bit automate it by using triggers and put some code that will do it for you, but it's not any build function.
Right. So basically, we are out of time. Just maybe before we go to this table, I will get back to it quickly. But about Azure, take a look at the hyperscale architecture. You still cannot define your old files, but there is a file groups. There is a strict separation between compute and storage, and it gives quite a lot more possibilities in terms of partitioning. But let's just go to the summary right now. And like you saw, in Oracle we have the most options in terms of the partitions, ranges, interval, list, hashes, and composites. Right, the SQL Server kind of is lacking of those possibilities. And right, so let's not read through the table, we just talk about it, but you can take a picture. The materials will be distributed. Also, some additional stuff will be available in the repository that we didn't manage to cover today. And right, so we don't have time for questions.
We can have one question.
Questions happened during us.
Yeah, so we don't have much more time for questions, but we will ask one from online. So Marcin is asking, have you worked with partitioning on SAP HANA?
Oh, nope.
Okay, so sorry, Marcin.
Unfortunately not.
Okay. Okay, so guys, last thing from me, because now I can tell you, this was my first ever public speaking, and I thought I will faint when I started. I thought I will literally faint here. So thank you for being with me.